An aeroplane propeller usually has 2, 3 or 4 blades, the angles of which can be adjusted by the pilot in response to airspeed and flight conditions. A propeller's main parts are made of aluminium because it's critical to keep it as lightweight as possible. The next item is sure to have you in a spin. The propeller's blades attach to a hub. This piece of aluminium is on its way to becoming that hub. Like the starting pieces for all parts, it was forged beforehand in anticipation of the final shape. This sophisticated computer-guided mill now machines the piece. 40 minutes later, the hub is finished and ready for assembly to the engine. This roughly shaped piece is about to become one of the propeller's blades. A lathe machines it to the final shape. Liquid lubricant washes away the metal shavings and cools the friction-generated heat. The lathe first forms the shank, the end of the blade that fits into the hub. The next milling machine cuts the blade's shape. Now the finishing steps, done manually because they require a keen eye. Using first a rotary sander and then a belt sander, the marks the machining process left behind are ground away. The metal is buffed with a polishing wheel. Then the blades are dipped in a strong detergent. This acidic solution eats away any dirt, oil or grease on the surface of the metal. After that, the blades are put in a bath of water and chromic acid. This seals the pores in the metal, fending off corrosion. The factory tests all critical parts for surface defects by dipping them in a fluorescent solution that leaches into any imperfections. After rinsing, the parts are inspected under black light. A blue glow means they're okay. Any imperfections show up as bright fluorescent green. The defective part is either repaired or rejected from the production line. Blades that get the blue light move on to the paint shop. A coat of black on the backside prevents sun reflecting into the pilot's eyes. And for safety reasons, stripes are added to make the spinning blades visible. Next comes a de-icing boot, a rubber-encased electric heating element that prevents ice buildup. The rubber is highly durable yet flexible enough to mold to the curve of the blade. Next, a part of the blade shank is lubricated with grease. Then a strong steel ball bearing system is installed. This will hold the blade securely in the hub whilst enabling it to pivot to change its angle. The shanks of the 3 blades fit right into this steel part called the fork. It keeps all the blades at the same angle. Next comes the pitch change rod. The term pitch refers to the angle of the blades. Engine oil will exert hydraulic pressure on a piston that moves the pitch rod, which advances the fork, rotating the blades to the required angle. The pitch change rod is temporarily removed and sealant is applied to the top half of the hub. It's then placed over the bottom half that contains the ball bearing set. A rubber seal is added. Then a sturdy spring to provide the required counter pressure. The piston and pitch change rod, which are now attached to each other, are threaded onto the fork. Another seal is added. This one prevents leaks from the top of this cylinder that will contain the engine oil. A special tool is used to tightly torque the cylinder down against the hub. Assembly is now complete, and the propeller is ready to go for a spin. Chocks away.